All right, so good morning and welcome to our last week of Geo-Python course. Sorry for being a little bit late to get started this morning, but yeah, let's do that. I think time-wise we'll be okay today. I don't think we have so much material to go through, but it does look like there are some questions here at the beginning to get started. And I would say that this is typically, seeing a bit more confusion here in week number 6 is quite common for the course, because when we get into doing things with pandas at first, it's relatively straightforward, I would say, in terms of reading in data files and looking through the data file that you've read in. But yeah, when we start doing things like grouping, it gets a little bit more challenging. And so we can review the grouping concept a little, and if you're still confused about the issue of grouping, you're also welcome to come and, for instance, ask us at the break or ask questions in Discord to get a bit more clarity. But you can see here from the feedback that's been input that grouping seems to be one of the main points of confusion, as well as the kind of looping with the key idea when using the groups. So first off, just the group by, grouped, these kind of things can be a little bit unclear, so we can review that. And then this, the two-frame, transpose, and concat stuff was also linked to what we were doing with the grouping, because what we were doing was calculating something and then putting it into a new data frame, and that's where this transpose and concat operations came in. And then there's a couple questions about, I guess this is probably problem 3 and problem 2 in last week's exercise, so we can have a quick look at those before we get started into the rest of the lesson for today. I think probably the easiest way for us to look at this is perhaps just to go to the course page, and if need be, we can open up something in the Jupyter notebook from last week. But one of our main tasks in last week's lesson was this idea of grouping as a way of aggregating data. So if we jump down to that section of the lesson, the basic idea was that we had observations of temperatures that were more frequent than, I guess they were several times a day, in fact. So you can see, for instance, here, just looking at the time column, that we have on the 1st of January of 1906, recording of temperature at 6 o'clock in the morning, at 1 o'clock in the afternoon, and at 8 o'clock in the evening. And the idea here was that we wanted to group things into a monthly value. So we would take all of the dates that we had that were for a given month, and if we could select every temperature for that month, we could then calculate what the average temperature was for the entire month. And actually, now that I think about it, maybe let's just go ahead and I'll jump over to the Jupyter Lab and open up our notebook from last week, because this will be probably easier to illustrate that way. So I'm just going to go into the My Work folder, to Notebooks, and then L6, and open up this advanced, whatever it is, advanced data processing with pandas. So this is the lesson file that we had for last week. And just like we did a moment ago, we'll scroll down a little bit here. I think probably what I have to do to get everything to work properly is go down and find the right section, which is going to be down here a ways, where we started doing the grouping stuff. Parsing dates, string slicing. So you'll remember, just as a reminder about that what we were doing was kind of taking this string of the date and only extracting the year and the month part, because that was going to allow us to find everything that had that same year and month. If we took only the first 6 characters of the date, we had the 4 characters for the year and the 2 characters for the month, and then we could make a new column where we had those values, and then we could say, okay, everybody who has the same year and date will do something with you, in this case, calculating an average temperature. So skip past the date time stuff. Here we are. So this is aggregating data in pandas by grouping. So what I'm going to do is I'm just going to click on this cell and then go up to kernel and restart and run up to selected cell. Basically, I want to redo everything in the notebook up to this point because none of the variables that are defined in the notebook from the last time we had it open are actually in memory right now in Jupyter Lab. So you can see the old output, but none of the variables have been defined in memory. So like we couldn't do anything. Like for instance, if I try to do data.head right now, if I just run this cell, it's going to tell me data is not defined because we haven't actually run all of the cells earlier. But if we select the cell here, for instance, and do this kernel restart and run up to selected cell, it tells me, are you sure you want to restart? And yes, I do. And it takes a moment, but it will basically do all the stuff that happened earlier in the notebook so that we can basically continue from here and have all of our data read into memory and all of that kind of stuff. I can tell here by watching this little symbol up in the top right that it's still busy. So it says it's executed 21 of 43 cells. I think if you remember last time we had this thing where we did the iter rows and used a function to calculate the temperature from Fahrenheit to Celsius, like kind of one row at a time. That was pretty slow, so I think it probably will take something like 45 or 50 seconds just to run that one cell because it's not a very efficient way to do things. We then saw how to do this in a more efficient way by using the apply method, but we'll have to wait here while this kernel is still busy calculating things earlier in the notebook. But then we can have a look at this idea of grouping just to clarify a few things. And if you have any questions, you're of course welcome to ask when we get to that point. So now everything is run up to this point, which means now if I do this data.head, no problem. Run all the other cells earlier. And as you might remember, this is our data file that we had a bunch of things in here, some columns we didn't use. But we had our time that was originally read in as a number. Then we had converted that time to a character string, and the reason for that was to do this thing where we wanted to extract just the year and the month. So we had made this year-month column by taking just the first 6 characters of the date, which again is the year and the month only. We had also done things like, just to mess around, made this date column using the pandas date time indexing, or date time data structure, and also the year month as a date time. But we didn't do any grouping with that stuff. We were just doing our grouping on the basis of this year month column. The idea was that every single row in the data frame that has a given year and month string, so all of the 190601 rows, would be made into a group by the operation that happened here. So we were taking our data frame, we were doing this group by function, and then we were grouping on the basis of the year and month. So every one of the rows that has a common year and month becomes its own group. We named this grouped. That was just the name of the variable, the name of the group object that was created by this function. We could call this anything we want. It doesn't have to be called grouped. But it just was the name that we had used. So we could call this data groups or whatever. It's just a variable. We're just assigning the output from this operation to some variable. We had called it grouped, but if you want to call it something else to make it more clear to you, that's of course fine to do as well. So, we could call it data groups if you want, just to sort of illustrate things. And to make a distinction, like group by is the name of a function, but grouped was just a variable name. So we can run that, and now we have to just change places where we refer to grouped to be the data.groups. But this is a data frame group by object. It's something that's in pandas. And its length, if we looked at it, was 601 because this is how many unique years and months we had in our data frame to begin with. And we had done this thing looking at what the keys were. So again, if we call it data groups, we had this .groups.keys, which was showing us that we had a group that was for everything that had 1906-01 as the year and month, then one for 1906-02. This was basically just giving us a list of all of the different individual years and months that were used to produce this set of different groups. And so you can see from the beginning to the end of this data frame, all of the different years and months of data that we had. Then what we saw in the lesson was if we choose a given month, it could be anything. We had here the month of August in 2019, and we just said, again, this is just a variable, so you could call this, some group or, August 2018, whatever you want to call it. We use this is not grouped now, but data groups dot get group, and then we're looking for the group that has this key. So you can see up here, there's the 2019-08, so it is one of the keys that we have here. And when we ran this, and again, I've changed the name to be August 2018, just to show again that it's a variable. What you saw were the rows from our data frame that had this as the year and month, 2019-08. So the output here should be every one of the rows from the data frame that had that year and month. It's basically allowing us to select part of a data frame and link a single key, in this case 2019-08, to all of those rows. I suppose that part was fairly clear. Then we got into this part about the for loops and grouped objects, which I'm guessing is maybe where things got a little bit less clear. And the idea here, I think in grouped we have called this not August 2018, but was it data underscore groups or something like that? I think that's what it was. That we were going to then want to loop over all of the different groups that we had in our data set. So all of the year and month combinations that we had, we can make a loop that goes through every one of those year and month combinations. And what it's going to do is it's going to find a key for each of them. If you remember up here, we had all of the different keys. So this is basically just the year and month combination. So it's going to find what year and month we have as our key. And then it's going to find all of the rows of the data frame that go with that key. So all the rows of the data frame that have that same year and month. Then there was the output here that it's just going to print out to the screen. The key is whatever. And then the first rows, it's going to do group.head. Again, both of these things are just variables, so you could call them something else if you wanted to. So if instead of saying key, if you thought it was more clear to say for year, month, I think maybe group is a decent name for this variable here because it is basically all of the rows of the data frame that go with that year and month. You don't have to call this key. It's just we had referred to it as the key earlier, so that was perhaps for consistency, but you could say year and month here just the same. And then this is going to print out group.head, which would be, as we saw above here, when we looked at the group we had, like when we got the group for the month of August of 2018 and looked at it, it was a data frame. And it was basically just the rows of our data frame for the month of August of 2019, sorry. Did I call that 2018? I did. So that would probably be better to do that way, just to be clear. But this loop is going to go through each one of the year, month values and print it to the screen, but we have the break statement here, so it's only going to do this once before stopping. So when I run this, we get the first year and month, which is 1906-01, and then we get the first 5 rows of the group of values that go along with that year and month, which of course is the first thing we have in our data file or data frame. And this would include all rows. I don't know how many there are in total that are in the month of January of 1906. but it would include all of them in the output here. The thing that's nice about this is now we have basically all of the rows for just the month of January in 1906, and we could do normal data frame stuff with it, like calculate average values for a given column. And that was essentially the idea for what we were going to do. We want to find an average temperature for the month of January 1906. Well, we'd make a group with all of those temperatures, and then we just take the temp C column and calculate what the mean is of all the values in the temp C column. But yeah, maybe some of the confusion was here in this idea that we're looping over all of the different groups we have. And the kind of main idea behind that is that this should be some list or some collection that the pandas group by function creates. So the data groups is basically just all of the different sets of data frames that go for each year and month that have been selected from our original data file. And then here, the key that we're using, or this time we called it year month, is just this way of identifying which group are we referring to. And then the group itself is going to be the data frame that has all the rows that go along with that year and month or with that key. Does that clarify things at all? I'm not totally convinced that it does based on facial expressions. So maybe I might ask this a different way. Are there other things, other questions you have about this kind of idea? We can get to this, the concatenate thing and the transpose example in a moment, but just about the idea. I mean, okay, first off, do you understand the kind of concept of grouping these things? That you can choose this string and you can say, okay, everybody who has the same year, month, you're one group. Once you have that, I think the kind of key thing is to recognize that with that group, you can then do these things like calculate what the average temperature is for all of the rows in the data frame that goes with that group. So this group by operation, it says for each one of the kind of year-month combinations we have, make a group, and the group that you create is itself its own little data frame that has only the rows that go with that year and month. I guess the group concept, that seems like it's a little bit more clear. Is that safe to say? Yeah? I at least see some people nodding. Yeah, looping over things, I get that this is a little bit less clear. I mean, if we want to, we could just comment out this. So we won't print out the rows of our data frame, but we can just print out the year and month by running this for loop. And so, you know, here you can see basically what you're doing with the loop is in the data groups, we have two things here. We have a year, month, and we have a group, and we're going through that. Let's just actually, why don't we just do this? Let's take a look at data groups. Okay, now the problem is it's going to show us. Yeah, we don't really get any useful output from this because it's a pandas group by object. I don't think there's an easy way for us to see the values here. Up earlier, now I've done this and made it print out a whole bunch of junk to the screen by commenting out the break. So somewhere up here earlier, we had printed out the keys here. So we had gone like data.groups, and then for all the groups, here are the keys, and you could do a similar thing to say get a single group and print the values for that group like we did here. I would say if this is still somewhat unclear, you're welcome to maybe ask questions at the break or also ask things in Discord, but are there any other kind of specific questions about this grouping and looping over the groups idea? Okay. in the absence of any questions, I'm tempted to kind of continue on with our lesson for today, but I will say before we do that, actually I'm just going to run this one cell with the break statement so I can get past all the output. The other question was about this stuff. So we had created this monthly data frame that was going to be the place where we stored our monthly average temperatures. We had set up this kind of set of columns we wanted to use. Then we had this loop like we just did above where there was the key and the group, and we looped over all of the different groups and said for a given year and month, let's do something with the data that go with that year and month. In this case, we did this grouping of the mean calls, which were the ones here, which include, of course, temp C. And we so calculate then what are the mean for each one of the years and months when we had selected those data. Then we added into this mean values a variable called year month that was equal to the key. Remember, these keys are just like the string 1906-01, 1906-02, etc. And then we did this stuff, which was the weird thing that we had to do to basically put this into our data frame. As a row in the data frame, we had to do two things. One was we had now this mean values, which actually we can go ahead and let's just do this. We'll add a break statement in here. And we'll maybe before we do this conversion, we can print out mean values. So you can see what it looks like before we do the operation here. Okay, it's not happy because I called this not grouped, but data groups. So when you run this, what you can see is that we basically, by doing this thing where we start looping over each year month and selecting all the rows of the data frame that we're going to work with that contain the temperature values for that and the wind direction and speed and gust and all of this stuff. We basically calculated for this year and month, 1906, January, what was the average temperature? It was this. What was the average temperature in Fahrenheit? It was that. Not a number for the gust. Maybe it wasn't recorded. Here's the average wind speed, and here's the average wind direction for that month. This is what our code is going to do for each one of the years and months that we have. It's going to calculate these things. And if you print it out, okay, this looks fine. We have all the information we might need. But the other thing is, if we print out the type of our mean values, you'll see that what we have is a pandas series. If you remember when we first started doing stuff in pandas, if you took a single column out of a data frame, it's a pandas series. It's a little bit different. In many ways, it's similar to a single column out of a data frame, but it is a little bit different. And what that means is that you can't just put this series directly into our monthly data frame. It has to be converted first to being a data frame instead of a pandas series. The reasons for this are probably going a bit beyond my understanding of how pandas works in detail, but essentially, when we take our mean values, we have to do first this two-frame conversion, which converts our series to a data frame. So, for instance, if we had like here, took our mean values and just added the two-frame function to the end of it, we can do that also here. And run this again. The output looks pretty similar, but you can see now that the type of data that it comes back as is a pandas data frame instead of a pandas series. And also, and perhaps importantly, you can now see that we have a column 0 here that is, that's just the number that's been assigned to this column. And then our row labels are here, the direction, speed, gust, temperature, whatever, and the year and month. This is fine, but in reality what we want is actually to have this be our row index and to have all this stuff be the values that are in a given row. So it's kind of the opposite of what we have right now. Right now we have this labeling our column and these things labeling each row. And what we want is just the opposite of that. So instead of being like oriented vertically, we want to flip this on its side, which means then this becomes a label for the row. These become the labels for the columns of our data frame. And that's where this dot transpose comes in. So this is kind of doing things in a fairly short way. We take our series, convert it to a data frame, and then flip it on its side. Again, if we just add that to our output from above and print out our now data frame that's been transposed and run this again, what you see now is that this becomes our row label, which is what we want. It's basically like an index. And then each of our columns now is dir, speed, gust, temp, f, whatever. This has all the information that we want now in the form that we want, because what we want to do ultimately is add in that each one of the rows is for a year and month average temperature. So when we start going through and doing this for each one of the rows that we're working with, we want to be adding in a new row with February, with March, with April, etc. And then this is basically the way in which we have to do that, is convert it to a data frame, flip it on its side so it's now having each of these things as column headings instead of labeling the rows. And then we do the concat thing, which is also perhaps a bit confusing. What we're doing is we're taking our monthly data frame and we're concatenating or adding together what was there already and the new row of values we've just calculated. So this variable row is what comes out when we basically do the stuff that's shown on the screen here. So we take whatever was in the monthly data and we add the new row to the bottom of it. It's like the append operation with a pandas or with a Python list. We're just adding things to the end of it. And we set this ignore index thing to be true because when we create this data frame, the index value that's assigned is always 0. So it would be confusing if it had the index 0 and then we added a new row with the same index value. In fact, it would most likely give an error message saying that you can't do that because it expects each row to have its own unique index. So that's why this kind of two-frame transpose and the PD concat stuff works like it does. There, I think as I mentioned in last week's lesson, there used to be an easier and kind of more intuitive way to do this, but it was not really consistent with how other things worked in pandas. So the developers of pandas changed it so that now you have to do it this way. And I think, unfortunately, it's not quite as clear as it used to be or sort of easy to understand as it used to be. All right. I think we've spent enough time on this. Are there any questions? Did that help, like, to clarify a little bit, like, what this kind of two-frame and transpose thing are doing? Yeah. So, I mean, you know, if we wanted to, we could basically, let's just show one other thing. So if key, let's print out just the year. So it would be 1906-12. So we'll let this loop go through for the first year of our data. So when it gets to 1906-12, it'll break our loop at that point instead of breaking it after the first iteration. And what I want to do is just, instead of printing out this stuff, we'll just print out after adding our new row, monthly data. And let's make this an F string. So monthly data as of, and this will be our key. And then we can have our monthly data. So this will basically print out monthly data as of whatever 1906-01, and then it should print the monthly data frame. And if we run this, this was never closed, right? If we run it with the proper, and actually let's add one more thing here. new line after that. So you can see as of the 1906 January, this is the output we have. Then in February, we add a new line. That's the February values. And our index value, by doing this ignore index, it always restarts the indexing when you concatenate and add a new row. It just adds a number. So you can see basically what we're doing is just adding a new row each time with the monthly values that have been calculated. So by the time you get to December, you have now the 12 months of values with these all as our different keys, and these are the monthly temperature averages that have been calculated. So I hope that helps somewhat. If it would be beneficial, we could perhaps extend the deadline for this exercise number 6 by a couple days. So if you were confused about this and would like another couple days to finish, I think we could extend it maybe till Wednesday or something like that, end of the day on Wednesday. So if you were having trouble and didn't manage to get things working, I guess actually, if you'd like the opportunity to go to the help sessions to get more assistance, maybe we could even push it to Friday for the deadline for exercise 6. I don't think there's any problem with that. So, yeah, maybe Kamyar, if you don't mind, to put a message into Discord just to say that before I say it verbally and forget. Yeah, we can extend that to Friday, the end of the day, so that if you need some extra help from the course assistants, you can go on Thursday and Friday for exercise number 6. But otherwise, yeah, I've used a fair amount of time here now, so we should move on to today's lesson. So let's do just that. So here we are, lesson number 7. And basically this week our focus is going to be on data visualization. So we've learned how to do some basic data analysis stuff. We've learned, the sort of essentials of Python and enough pandas stuff to allow us to read in data files and do some data analysis. And now we're going to focus on how to visualize our data. And so our goals here are going to be somewhat simple in terms of the visualizations that we'll produce, but we're going to be doing things like making some XY plots of data using pandas and Matplotlib, which is a plotting library, as the name might suggest. How to manipulate different parts of the plot. So this is things like adding axis labels and changing various things that are part of the essential elements of the plot, and then also how to both make plots in Jupyter notebooks, but also to save them as image files that you might like to use for other purposes. And to get started, we can have a look at some of the different available plotting libraries in Python because there are quite many of them. And this little image here on this plotting in Python page shows you some of the main libraries from which different plotting libraries have emerged, or different kind of tools or packages. So some of them are based on JavaScript, some are based on OpenGL, and others are based on the sort of old school Matplotlib library that we'll be learning, which is the kind of foundation for a lot of different plotting libraries in Python, including, as you can see down here, pandas, which uses Matplotlib in its built-in support for making plots. So this is the kind of network of how all these different plotting libraries relate to one another. And we'll also, in addition to doing some plotting with pandas and Matplotlib, we will use HoloViews just briefly at the end of the first part of the lesson today, because it allows us to make interactive plots in a nice and easy way. But you can see here perhaps that things are a bit complicated. There's lots of different options. So we'll introduce you to Matplotlib because it's the most common. But if you start looking around for plotting in Python, you're going to find examples of people showing how to do things with Plotly, how to use bokeh, how to use many of these different options for plotting. HoloViews is quite popular, but Seaborn is very popular for making statistical plots. There's just a lot of different things that you can use here. So it's might be a little bit intimidating, and that's why this page exists. So on here, you'll find a list of some of the more common plotting library options in Python, as well as links to things like the home pages. What's particularly useful, I would say, with these different homepage links is you can go to things like here, the Matplotlib gallery. And if we open this up and then make it a bit bigger, you can find examples of different types of plots that you can make with Matplotlib. So if you find that you were interested in making a plot that looked like, I don't know, let's see if we can find something that looks sort of interesting. How about one of these nice contour type plots? So imagine you wanted to make some kind of contour plot like this. You can click on the example in the Matplotlib gallery, and it actually gives you the code to be able to produce that example figure. So if you wanted to make a, let's say you had some idea you wanted to contour your data and have it look something like this, you can find examples of how to make your plots look this way in the Matplotlib gallery, which is really nice because oftentimes, even with a fairly good understanding of how Matplotlib works, I still will often go here to the gallery to find a plot example to start from, just because it's a quicker way to get to what I ultimately want to be plotting. And so I would say it's worthwhile. You can go and have a look and see, there's lots of different examples of how to do things like use different line, like if you wanted to do something where you don't have colors, but instead use dashed lines for negative values and solid lines for positive values. They show examples of things like that. How to change the different colors and things like that that you're using for the contour lines, how to fill in the background and use different colors, etc. So it's really handy place to go and have a look if you're interested in seeing how to do different plots. And the same thing can be true for some of the other galleries, like with Bokeh, which is often used for making interactive plots. Make it a bit bigger here, but we could go and find, let's see if we can find a good example of an interactive plot. Maybe something like this. But you can go and you can find example plots. This is a static one, unfortunately, that comes up in Bokeh, but also it shows you the Python code for how to reproduce the plot. So again, if you want to figure out how to produce a certain type of plot, this is a quick way to be able to do it. We should be able to get one of these that's actually coming up as interactive. This at least should be interactive in principle, and it looks like it is. And usually, this is maybe less interactive than I would normally like. Oftentimes you can click on different things in here to make them appear or disappear, but there's lots of different options here. It's often the case also that you can mouse over values and see, for instance, the values that are associated with things, but it's not, maybe these plots aren't configured to allow you to do that. But the point is you can go and you can explore, see different styles of plots, and then use those as examples to get yourself started. So you can find some descriptions of different things here if you're interested to learn more about the different plotting libraries. Essentially, this is just a resource for you to use and go and do just that. I think maybe in the interest of time, we'll leave it there for right now. But please go have a look. Another thing that's worth noting here is there is this information about the kind of anatomy of a plot, which is basically just the essential elements of what we would consider a typical plot in Python and in many different settings. There's also a list here of different styles of plots that are just links to, for instance, Wikipedia articles for scatter plot that kind of describes what the plot type is and gives you the kind of general information you would expect in Wikipedia about, for instance, a scatter plot. So again, you can go, if there's a certain style of plot you've heard about, but you don't know what to do, you can look here and, if you've heard of chord diagrams, but you're curious about what they actually are, you could go and see, yes, that's the thing I'm interested in, and then you might be able to find an example in Python with one of these plotting libraries that you could try to make your own chord diagram. But beyond that, there's an example here of the basic elements of a plot, which is essentially just the sort of annotated plot with different things labeled on here just to make it clear to you what are the names that are used to refer to the different things on the plots. And this is kind of in the Matplotlib terminology. So, okay, I think everyone's aware that, you know, the text you put at the top of the plot would be the title, nothing surprising there. Also that you have these X and Y axes and you have labels on them. But, you know, things like the tick labels are sometimes used, like given a different name for different plotting programs. And things like the filling, this is often can be referred to by other things as well. Padding is sometimes a different name. So this is just to kind of tell you that the space between the axis and the label, in this case, is what's called padding. The color that's in between two lines is called filling or fill. And then the text on here is often referred to as annotation. If you're trying to figure out how to adjust something in one of your plots, these are the types of terms you're going to want to be searching with in a search engine to be able to find some way to do what you want to do. So there's the example here of, okay. That was fun. There's the example here with all the different things labeled on it, and you can also then find a description of the different terms down below. So if you're confused about some term that's used in the lesson about plotting or something else, you can find a description of some of the common terms down here in the bottom. But let's actually do something now. Let's get started with doing some plots. And in order to do that, we're going to go back to Jupyter Notebook, to our Jupyter Lab environment. And first thing that I need to do is go to the Notebooks folder, and you might need to do this too. Go to the Git plugin and pull today's notebooks. So I'm just going to click to pull the Lesson 7 notebooks. If you have any trouble with that, let us know. Maybe Kamya can give you a hand with that. But we're going here to Lesson 7, and the first notebook we're going to open is called Matplotlib. So I'll just double click to open this one. We're going to more or less be working with the same data set that we used last week, so we don't need to actually do anything in terms of loading in our data. We'll read things straight from Lesson 6's data files that were there, and we can get started. If you want just to remember what the data are that we're working with, there's a description here at the start of the notebook, but it's the same thing we were doing last week. And to get started, like always, we're going to be using pandas to read in our data file, so we have to import pandas. And we're going to run the first couple cells here. So we have our definition of the file path. This again is going to read out of the shared folder our data file, which is already typed in for you. And now we're going to read in our data file pretty much like we have earlier. So here's the file path. We're using this delim white space to say that if there's spaces between the columns, that's what we'll do to separate the different values in the columns. And here we're converting the star characters to not a number values. We're only going to use certain columns. So here the date, temperature, the max temperature, and the min temperature. But what's different are these two. We haven't done this earlier. So last week we saw this date time idea where you could convert this kind of string of the date into a sort of different type of data in Python that was used for representing dates. And then we could do things like, extract just the year or the month by taking whatever our date is and doing like .year or .month. You can do this conversion on the fly when you read in a data file in Pandas by saying two things. One is that the column we want to read in and convert to dates is this year, mo, da, her, m column, which is our date column. We want to convert that value into a date time representation. And we're actually going to use that as our index in the data frame when we read it in. So this will allow us then to have our values, each row will be indexed by the date. So instead of being like 0, 1, 2, 3, 4, it's going to be the date that goes into those places for the index. So we run this. It takes a moment to read the data file in. And after that, You can see again the description here of what the parse dates and index call are doing. But if we take a look at our output here from running data.head, we see our temp, max, and min columns, and our index here is now this date that's being used to represent each one of the rows here of our data frame with the format of a date time object. So you can see here year, month, day, and then the time of the day in the format of a date time object. We'll come back to this in a little bit in terms of why we do this when we want to start plotting things, but it will become maybe a bit more clear when we start doing the plots, and we can look at some of the different plot options. But yeah, let's make our first plot here. And the way that we're going to do this is we're going to create a variable called ax. This is a typical way to make a plot in Python, is that you assign the plot output to a variable. This allows you to do things like modify the plot once you've defined the ax variable. And for us, we're just going to do data.plot because we've read in our data as data frame. And if we just do .plot, we can use the built-in plotting in pandas to produce a plot. And if I run this cell, you should hopefully see the same, that it takes a moment. But we'll get some kind of noisy looking thing in just a second here. So you should hopefully see output that looks somewhat similar to this. And what we can see here is, you might have noticed at the beginning when we did the data.head, we had data that started in 1952, so about here, and did go through until I think 2019 at some point. And in that data, we had temperatures in the variable called temp. We also had some max temps that you can see in orange in different places. Min temps you can see perhaps as these green dots. Maybe I'll move this out of the way and I can make this one click bigger. But there's some small green dots you can perhaps see here. Those are the minimum temperatures. They're not very continuous, so it's just showing up as single points, whereas there are a couple places where the max temperature seems to be a bit more continuous. But the main thing to focus on is that we have the variation and lots of wiggles in the temperature for the average temperature that was measured for each one, or actually it's not the average temperature, but the observed temperature at each one of the times in our data set. Along the horizontal axis, you can see that we have the year, month, day, hour, minute, whatever, our label on the axis here, and you can see now our years, so from 1950 up until 2020 on that axis. Part of the reason why we read in our data and used the date time representation as the index is that what pandas will assume by default when you do this data.plot is that whatever the index value is will be used as the horizontal axis value. So in this case, it's the date that goes here, and then each one of the columns gets represented on the vertical axis. We're missing a bunch of stuff from our plot, like we don't have any labels for a lot of things, but you can see overall that we ended up with a plot that looks like it's got our data represented in a visual form, and we have some place to work from there. So we use this .plot to make our plot, and we assign the output to a variable called ax. If we check the type of our variable ax, what you'll see is it's a Matplotlib axes object. So basically it's a set of plot axes that are part of the Matplotlib library that is, as mentioned, being used by pandas to produce the plots. We don't really see Matplotlib, we don't import it here, but it's being used in the background to produce our plots. And now we'll learn how to do a little bit of manipulation of the plots. And we'll do that with a little bit simpler set of data. So rather than using everything from 1952 to 2019, we'll just pull out a much smaller data set. And we could do that here by making a new data frame that's our oct1 temps. We'll do just the dates for 1st of October 2019. And from this, we're going to take it out of our data frame, and we're only going to take the temp column because we don't need to worry about the max and the min. That's just unnecessary for our purposes. And we're going to use the .loc method in pandas to select all of our values where the data.index is greater than or equal to, and then here we say 2019 for the year, 10 for the month of October. The 1st of October is 01, and then I think in this case we're actually only going to take dates from the afternoon of the 1st of October, so we can put in then for the hours 12:00. So again here it's the year, then the month of October is the 10, the day is the 1st of October, and then this 12:00 would represent noon. So this should be selecting from our data frame only the values where the date is greater than the afternoon of the 1st of October. The end of our data file is the end of the day on the 1st of October, so we're going to end up with basically half a day's worth of data. And then if we take that and we do AX equals oct1 temps dot plot, we can do more or less like what we had done before, but now we're going to plot just a much smaller amount of data. So if you run this one, what you should see, first off, is it plots a little bit faster. But secondly, we get now values from here's October 1st at 12 o'clock, 2 o'clock in the afternoon, 4, 6, 8, 10, and then at midnight. And you can see here that on the vertical axis, these are the temperature values for that date in Fahrenheit. So I think nobody would expect, I don't recall which station this is in Finland, but certainly there wouldn't be temperatures of 40 degrees in October. So yeah, we now have this smaller subset of our data that we can explore a little bit. What did we do? Well, we selected only the temp column, so we don't worry about the max and the min. That's not a big deal here. And we used this restriction that we said, okay, well, we only want things from the afternoon of the 1st of October. So we just checked our data index and said, okay, if your date is greater than the afternoon or greater than noon on October 1st, then we'll take you. And then save that as oct1 temps so that we could do this oct1 temps dot plot, which makes the plot that looks like this. It's neither. It's not a string or an integer. It's its own kind of data type. And it's basically designed specifically to represent date values in Python. So in selecting things here, you can do this kind of index where you say that the date is greater than this and use a string here. I don't think this works if you try to do it as a number. Yeah, it'll fail like that. It seems to know that when you're doing a comparison with a datetime object, if you compare a string to it, it seems to know to automatically convert that to its equivalent as a datetime and then do the comparison. So it's kind of hidden in the background, but this seems to work if you put it as a string, but if you put it as a number, it won't do that conversion properly. So you could, I don't know what's going to happen here because like in order to do the automatic conversion for this string to time, I think it's going to need at least the full year, month, and day. It only has certain kind of string formats that it will automatically recognize as like, oh, this is a date and convert it. This way, if you put it like 2019-10-01, it gets the whole day of October 1st. So you can leave out the hour and minute part. My guess is if we left off the day, it's not going to know what to do. So basically, this is not enough information for it to be able to know, like, are you trying to refer to a date with a year and a month or what? Because like you could represent, if you truncated the year to 2 characters, it could be a representation of the year that way. So it just sees like 6 numbers and says like, I don't know what to do with this in terms of automatically converting it. So if you were to want to select things like single months out of there, why did this now not work? Oh, right, because there is no... we don't have anything for the 10th of October in our data file. If you want to convert things, like there are ways to select months from a date time object. I don't know if I'm going to remember how to do this by like off the top of my head, but I think it's PD2 date time. And then you can put in some string here like 2019 10/01 12/00. Which converts it to this kind of date time object. You can see it comes back with some additional stuff here that tells you it's not like a normal string or not an integer value, but it actually converts it so it knows certain things like this. In fact, we could even, like if we said it was 30 seconds after 30 seconds after noon, you can add in like even the seconds here and it will convert this string. It knows certain styles of things like this. I think also if you have like dashes between these different things, I think it can recognize that this is a representation of a date. If you put them in different order, like if you go with the, so I guess we could do it like this. It also can recognize that that's representing a date. So there's certain kind of expected formats that can be converted to the date time automatically, either with or without the kind of hours and minutes included there. It just assumes midnight if that's the case that those are left off. And if we said like October 1 equals this, and we made that, we could print out October 1, which is what we just saw, but we could also print out, I think this will work if we do oct1.month. That didn't work. Oh, it might be that it's representing, it might be assuming a sort of, it might be the sort of US style that it assumes the month is first and then the day, if you put it in this way. So let's do it like we did before. So 2019 10/01 will be our October 1st. And then, yeah, if you do oct1.month, it can give you just the month out of it that way. Oct1.year can give you that. And I think oct1.day would give you, that's the first. So it has its own kind of built-in set of functions that allow you to do date stuff. We only kind of touch on it a little bit because it gets a bit more abstract, but it's quite powerful to deal with dates. At least for plotting, it does things really nicely. Like if you have, let's say the worst case scenario here, you have a data set that goes from, let's say the 12th month, so 31st of December, which is now, okay, now December 31st, whatever. Okay, I got to run this cell first. We know that between December 31st and the 1st of January 2020 is 1 day. But if you look at it as a number, and I'll just delete the stuff here and just say we had 2019 12/31, the next day in this format would be 2020 01/01. And if you took these two numbers and subtract them, you end up with something like, 8,870 as the difference between the two instead of a difference of 1. So when you're plotting things, you hit, like if you don't convert it to a date time, you can end up with these weird jumps in there. Like every time you hit a new year, it shifts all your points with a bunch of space in between them and then plots them like, 1 day apart, because like if you took the 1st of January 2020 and subtracted the 31st of December, you end up with this big difference. But if you took the 2nd and subtracted the 1st, of course, you end up with a difference of 1. So like within a given month, the points are only 1 apart on the horizontal axis if you don't convert them to date time. So date time handles these kind of things like going, okay, yeah, it's only 1 day apart in like on the plot, so we should only have things like separated by a single value on the horizontal axis rather than whatever it was, 8800 or something like that. So there's a lot of reasons for doing the date stuff. And yeah, if you're curious, we introduced it back a little bit in last week's lesson quickly, and then you can find more links and things like that about date time in last week's lesson. Okay, before we take a break, I would like to just go through a couple things about formatting the plots, and then we are due for a break. I'm aware of that, so don't worry. So we had our example here that we made this plot above for October. Okay, it was the afternoon, so we had like done like this. Afternoon of October 1st in 2019 and gotten some plot that looks like that. But we know it's missing stuff and we might want to be able to modify our plot. I'm just going to cut these two cells to get them out of here for the moment. So let's get into then doing a little bit of plot formatting, and then we'll take a break after that. So first off, we're going to make a plot. So we'll say AX equals, and we'll do oct1 temps, just like we did before, dot plot. But instead of just now closing the parentheses here and pressing enter, we're going to add some stuff in here. So I'm going to hit enter to put something down on the line below here. And I'll first add something about the style. And I'll explain what this means in a moment, but you can just do R, O, and then dash, dash. We'll sort of clarify what that does in a moment, but we're going to change our plot style like this. This is using some kind of shorthand. And we can also add a title. And we'll say, for example, our title is Helsinki Vanta temperatures on October 1st, 2019. You can put something shorter if you want. But we're just adding a title. Doesn't matter what you put there, just to show that we have a title. Then we have an X label, which is used to label the horizontal axis. So this should be our date and time. Then we can add a Y label as well. And our Y label in this case we can call temperature. And we'll put it in degrees Fahrenheit. And then we can close our parentheses after that. So we're adding the style, we're adding a title, and then we're labeling the axes. And again, for the title and the axis labels, you can write something a little bit shorter if you prefer to save a bit of time typing things in. So if you run this, what you should see is the basic same information on the plot that we had previously, but now you see that the line color has changed to being red. It's a dashed line, and there's also these circles or points representing the values that are the measured temperatures in the data set that we're plotting. So looking at this style thing here, that's what's changed most of what represents the plotting of the line. And what we did is we used the shorthand, which says if you put in for the style the letter R, it will use the color red to represent the line and symbols. By adding in the O, we're saying that you should plot these symbols, the points, as circles. This is again the shorthand, and then the two dashes are meant to indicate that you should use a dashed line. Now, I don't expect you to just kind of remember how to do that, but you can find documentation on the Pandas webpage that explains this shorthand notation so that you could learn things like the very unintuitive letter K being used to represent black. So if you want to make your line black, it's the letter K because the letter B is used for blue, so then the K is used for black as the last letter of the word black. But I think also like you can use G to represent green. You could change your symbols from circles to stars by putting an asterisk in there, for example. So then you can see you get star symbols. And I think if you put in maybe the colon character, it will do a dotted line. Yeah. So anyway, you can find that there's like shorthand stuff for this. If you look in the pandas documentation, it tells you what the different colors are and things like that. You can also do more sophisticated formatting things, but this is just to kind of introduce to you the idea that you can do formatting stuff like this. So I'll put this back to the RO dash dash that we had to begin. And yeah, of course, you can see also that now we have our title of our plot and our labels for the two axes as would be expected. Now I'm going to copy this cell at this point because we're going to use this one down below as well. Or I'll just copy maybe the code part of our cell. All right. What are we supposed to do here? I don't remember. Oh, right. There's the help. Yeah, I guess if you wanted to, for instance, you can do the help command on the oct1 temps dot plot, which if you run that will give you information to explain some of the different variables and values you can use to make plots in Matplotlib. As you will see, there's quite a bit of information here that gets output to the screen, which is why this is not done on the course webpage and why I sort of regret doing it now because I have to now scroll past all of this stuff. But it's fairly complete documentation. If you're wondering about plotting stuff, you can run that command and then get ready to scroll because it's, I don't know how many lines of output this is, but it's a lot. Yeah, good reason why we don't do this on the course page. Oh my goodness. Okay, so after several thousand lines of output, we come here to the two things that I want to do before we take our break, which is one is embiggening the plot, which is a reference to The Simpsons. If you're not, don't have any familiarity with the word embiggen, you can look at the links here and probably find the clip on YouTube about embiggening. But the basic idea is if we take the output that we had before, I just copied this from above just to avoid having to type it in again. We could add one additional thing into what we had output before, and that is to say our fig size, which is a size of our figure that we're producing. And we can say fig size equals 12, 6. And in this case, the figure size that we use when we're using Matplotlib, because it was developed in the US, is figure sizes in inches. So this would represent a figure that's 12 inches wide and 6 inches high. So just be aware that sometimes the numbers in here might seem a little bit weird. Of course, they are going to scale relative to one another. But if we run this, what you should see is that now your plot is wider than it was before, and perhaps I think also a bit higher or taller than it was before, but has all the other output that's the same. So you can use this fig size parameter to allow you to vary the size of your figures. That's a handy thing to know how to do. And you can also, if you want, see there's a note here about how to make all of the figures in your notebooks follow a different size by default. But you have to import Matplotlib to do that. Okay, so a couple other things. Again, I'm just going to copy what we have here to be able to paste this into the cell below. But the next thing we'll do before we take our break is to add some text on our plot. So you can, of course, add text to the plot to display something there. We can also change the axis ranges. So if we want to change the minimum and maximum values on the horizontal or vertical axes, we can do that. There's also something here about dealing with our date time axes, which we can just, again, I think we've already now maybe seen this, but if we took our pd.to date time like we did before, and we had some string like 2019, 10:01, and 1300, you can run this and see it will be converted to a pandas date time format. We just did that earlier, so you don't need to do that again. But if we wanted to take the same plot that we had before, okay, actually, luckily we don't have to copy paste anything, it's already here. We could change it so that our range of dates is from only noon until 3 p.m. on the 1st of October. So we could do that by setting up a variable here called start time, which we could say is pd dot to date time. And we want it to be noon on the 1st of October. So this is going to be 2019 1001, so 10th month, first day, and then 1200 for the time of 12 o'clock. I'm going to copy this just to make this easier to type in, because the next thing we want on the next line is our end time. And I'm just going to paste what we had above and just change it from 12 o'clock to 1500, 3 o'clock in the afternoon. We're going to use this then to select only a certain range of dates. And yeah, we do have to convert this to a date time thing in order for this to work with our plotting approach. The last one is the cold time, which we're going to pick the coldest time of day and add some text to label that. And in this case, we know that the cold time is going to be at 12 o'clock. So I'm going to copy what we had above. And I'll make one minor modification to it here, and that is to make it 5 minutes after 12 o'clock for the cold time, because we're going to add text to our plot at that time to identify that that's the coldest time of day. But I'm going to shift it 5 minutes off of the plot so it doesn't plot right on top of the line that we're plotting, just to make things more clear. Otherwise, we have the same stuff we did before, and then we need to add a couple things here, like our x-lim. So this is the limit for the range of our x-axis. And our x-lim is equal to, we're going to start with our start time and end with our end time. And those are going in as a Python list, so you can see that it's in square brackets. And then our y-limit, so the range for the y-axis, is also going to go in as a Python list. And we're going to say it's going to be 40 degrees as the minimum and 46 degrees as the maximum. And then finally, we're going to add the text to our plot using this ax.text. So ax creates the plot axes, and the .text will allow us to add text to our plot. And we want that to be on the x-axis at the cold time, on the y-axis at 42 degrees, and then we're going to add some text that looks like a little arrow pointing over that says coldest time of the day, or something like that. I guess it's coldest time of the afternoon. A lot of stuff to type in here. But in essence, what we're doing at the beginning is we're just saying, okay, this is going to be the first time that we consider in our plot, which is noon on October 1st, 2019. We're going to only plot things up until 3 p.m. on that same day. And then at 5 after noon, we're going to have the label for that being the coldest time of day. And that's basically where we're going to position our text on the plot. And the text we're adding then is what's down here. So when you do this ax.text, it's essentially saying what's the x position on the plot, what's the y position. So we have this at the cold time of day and at 42 degrees. And then here's the text that's going to be plotted. And it just says coldest time of the afternoon. Otherwise, you can see that we've set the limits for our x and y axes as listed here. So if you run this, you'll get a modified plot. You can see that everything is sort of looking generally similar to the plot style we had earlier, but now we start at 12 o'clock and only go till 3 p.m. on October 1st. And we've added the text here to label the coldest time of the afternoon with a little arrow pointing over to that point on the left side of the plot. All right, at this point it's a good time to take a break. I think we can take the full 15 minutes. And we'll leave you with this check your understanding thing so that either now or after you come back from the break, you're asked to make a modified version of the plot we just made with the times from 6 p.m. till midnight on October 1st, and then make some modifications to the text that's shown on the plot, etc. So yeah, let's come back at 10 minutes until 11, so 15 minutes from now, and then we'll continue with the rest of our plotting lesson and introduce the exercises, etc.